take this opportunity to introduce the next session, if you allow me to. So we have, so open source is all about collaboration, and we actually have the team here from FOSDEM. So I don't know if any of you have attended FOSDEM in the past. This is the biggest open source conference in Europe, and they are basically the main organizers. So they came all the way to help us with the video and streaming for this event. They're gonna give a talk about the FOSDEM Video Box. So the open hardware that they build to do like streaming of multiple rooms at the same time for their conference in Brussels. And here I have Gerry, Mark, and Vasil.
So, hello everyone. So I hope this is going to be a good talk because we wrote it yesterday. I've completely forgotten most of it already. So I have something written up. No, I should be able to stand for 30 minutes. So okay.
We might fall asleep if we sit down. So.
Yeah, that's actually right. So what's this all about? This is the video box. This is a closed one. This is the video box that we did FOSDEM 2025 with, and that we're testing. We're using to do the video at FOSSASIA. We have one open right there, which you can pass around so you can see what's in it, and we're going to explain parts of it while the talk goes on. For anyone who will be bored listening to us, these URLs contain the sources, the hardware schematics, the history of what we did, how we did. So if I'm boring you to sleep, that might be the more interesting thing for you. So there is one special slide I wrote exactly for this. And this might be the larger reason I did this talk in general. Because I spoke with some of the volunteers and some of the people around here, and they looked at it and said, wow, what's this incredible thing? It's not. This is not hard. This is something that a few slightly insane people made in their spare time. There is nothing extremely hard about it. There is nothing very special about it. And it's something that everybody should be able to play and hack with. And I even have a joke, which I hope translates well enough, which is about a mathematician, George Danzig, who, when student was late for a lecture, came after the lecture, saw two mathematical problems written on the blackboard, thought they were homework, copied them, went home, and managed to solve just one of them. So he goes back the next day, just a bit earlier this time, and asks the professor, so I was able to solve the first one, but what about the second one? I wasn't able to. Is there something that I'm missing? And the professor looks at him, what homework? There were two problems written on the blackboard, but these were unsolvable problems. And so that's the thing. He didn't know, and he solved one of them. And if you don't know that something is possible, and if you don't decide something is impossible, you will be able to do it. So I have a few interesting pictures just to show that you should not be afraid to experiment. This is one of the setups we did for testing the audio mixer. And as I'm saying, don't be afraid to experiment. I'm not sure if you can see most of this, which is soldered on one place and which is a power supply. You should not be afraid to do stuff like this. It is strange, it is weird, it might catch fire, especially this thing. So you just keep your fire extinguisher close and keep hacking on it, and at the end it will work, and when it works, it's great. A short explanation on what's FOSDEM. Free and Open Source Developers European Meeting. It's his fault. The name, I think, is his fault.
I'm sorry.
Yeah. But it has about more than 8,000 visitors. For 2 days, it has about 1,100 talks and 30 parallel tracks. So there are 30 rooms in our very large campus. I'm going to show. There is a number there. 160,000 square feet.
No, meters.
So
1.8 million square feet.
Yes. A very large place with a lot of rooms that we have to set up to make working and have video for all the rooms. And we don't have a lot of time. So we have to set up this in the day before the event. It has to be working. And for the next 2 days, it has to be it has to be good because people want to see it. So I'm really, really happy to be part of it, whatever I tell to Gerry, because this is something nobody else does. I mean, nobody is as crazy as us to do 30 parallel rooms with less than 30 volunteers. And here is an explanation of the problem in depth. A large event, large venue, a lot of things to do, and not enough budget. I mean, I'm pretty sure that if I talk to a few companies, I say I have unlimited budget, they'll come and make the video. Or not. I don't think anybody will be able to do 30 rooms in parallel, but I mean, it's not an option just to throw money in it and see what happens. A few details on how the setup looks like. And we're doing something close to this at FOSSASIA right now. You have a room. A room is pretty self-explanatory. You capture a camera and a presenter, the presenter's slides. You push this to a video mixer, which mixes it and it's controllable remotely. And the stream from this mixer goes to a stream backend, front-end, and to the internet so people can see it. There are recordings happening somewhere here that are used then for the review, because the review is the review means that every speaker and dev room manager receives a list of links where they can say this from this time to this time is the videos, and they can do the actual processing of the video that's going to be released afterward. Because 1,000 talks you can't do by yourself. That's just too much. And well, as you see, such a setup would require a very large and serious computing power for the video mixing, or not, I'm kidding. These are about 30 10-year-old laptops sitting on IKEA wine racks in a server room somewhere.
They give very good ventilation.
Yeah. Yes, it's cold in Belgium. So these ones run software from C3Voc, the guys that do the video in CCC called Voctomix, which is a very simple software that pretty much written in Python that takes video stream, GStreamer video streams and does the mixing. And I have to go back to the slide. I said this is not complex. This is the total amount of lines of source code for the infrastructure and most of the video. So there's some code for firmware and stuff like that. But this is 1,000 and less than 500 lines of code.
Glue.
Mostly,
code.
yeah, glue, exactly. So it's not that we three extremely smart people sat and wrote something very good together. No. This is glue. We used whatever exists as open source. We released our stuff as open source, and this makes FOSDEM Video work. I have a question.
Are these actually physically lines of code? Are they etched into stone or something?
So the question is, are these actual lines of code? Yes. This excludes empty lines and stuff like that.
No, it's physically etched into stone.
No, we just print out every release.
And historically, so FOSDEM has been there for 20 years. I'm not going to go back into the beginning when we used FireWire cameras and stuff like that in the olden days. This is the previous video box, which used, I don't know if you can see how thick this wood is. This is laser cut wood. Maybe Mark, you can explain better what this was.
Oh yes, this was a sweatshop in Latvia producing it.
So this is laser cut wood assembled, and then in it you have a power supply, you have an encoder, and you have a banana pea which takes care of the encoding, of controlling this, and a very large power supply.
And all of these components were off the shelf, so
Yes.
nothing was homemade.
There's another type of box which was made for slides because it has a scaler, which is a specific device that you plug in any kind of laptop and it would output a signal which is readable to the encoders, because laptops manage to output, this is one of the hard problems. Laptops manage to output some very strange signals, and which signals can confuse the encoders, and this is one of the reasons we're considering banning MacBooks from conferences.
As you might have noticed, some projections end up being yellow on the screen. That's because of MacBooks.
And that's one of the smaller problems. And for 2024, we did a test run with a smaller version of this, which was mostly this kind of box, but we used the laptop. So a laptop which connected to the encoder and to an HDMI capture card. And it was very nice because the laptop has a large screen, it has a built-in UPS, stuff like that, which is very useful, but it's very large and unwieldy. So some people are holding the box. You can see how small this is right now. And we can manage to put all the stuff inside. And then Martin Bram came to the NOC in 2024 and said, you know, I was bored and I made an audio mixer, an open source audio mixer. I think that might be useful to you. So we thought we can throw away half of the stuff we carry around. We can put this in the box. We can try making our own hardware for the box. Why not? Oh, there are a lot of reasons not to. So then we found another person in our senior staff who helped with the design
As
of
you
the
see,
hardware.
he's
Yes.
very senior.
Yes, and he has the important tools that we needed for some of the work. So this is the other person designing hardware, and this was our motto. Everything you see in this box comes from this thought. We wonder if there is a hacker solutions, and there almost always was. And at the point you start making your own hardware, you start to get really, really greedy, because what else can you do? I'm not going to even read through all this. This was our thought process, like, can we add, we have an audio mixer, we have this screen that fits very well and it has other pieces. Can we just have the line levels on it? And you can see on the switch, on the audio mixer, that there's a place for something. Can we add a receiver radio for microphones? And all kinds of such crazy things that we came with. Some of them are already in there, some of them are not yet. But for example, we isolated the power, so this thing can power receivers and stuff like that. We made our own switch because there is no 5-port switch. Most switches have ports on one side, and this was easy to do, and we made it. Now, I'm not sure how many of you say it should be easy to make a network switch, but it turns out it's not that hard. And so we spent the summer working on it. So these are random commits from the repo. I just pulled some random commits, for example, bigger inductors for the power board. Or another experiment, or somewhere here I think was the base plate. So you see that there's a large metal plate underneath. It had to be a bit shorter to fit in the case. So there were back and forths for a while. I think there is, if this slide, if this was a movie, this slide would have been a montage with music of people working. And so we got it assembled. This is the diagram of how the assembly happens for the box, which is, it looks hard. It is not. This is the pretty much steps you make to just have this assembled. And it took, I think, about 10 people, 2 or 3 weekends to assemble 70 boxes that we were able to make FOSDEM with. Here is a small photo of it. So
the Bulgarian sweatshop.
Yes, this time it's a Bulgarian sweatshop. And because we were running very late, this happened between Christmas and New Year. And I don't know how well this translates with the holidays here, but let's say we were pretty much the only people working in the whole country at that point. The rest were drunk. And we managed to do FOSDEM 2025 with it. So this is a full box, which you have, these are the outputs for the room and the camera. There are the inputs for the microphones.
So basically, this microphone would be connected wirelessly to this receiver. It would go inside, be mixed, and then go out to the PA in the room.
And to the camera, yes. You have the screen which shows what is, this is the slides box, so this is the slide coming from the speaker. These are the microphone levels. This is charging for the different things. On the other side, you have Ethernet, power, and the HDMI going in, which I can't show right now. And so you can imagine, so we did this, we were ready 2 weeks before that. We were even getting so late, we thought we might have to rent a truck, drive from Bulgaria to Belgium and assemble stuff in the back on the way. Didn't happen, thankfully, but we were very, very close. And this worked. So we still can't believe this worked. We had the... and here is what you also, back there, this is the box itself. I open one that you can see the different pieces in. From this box, there are 2 boards which were not designed by us and 1 piece. So this is HDMI capture board with loop out that's used right now. It's based on the microsilicon MS2131 chip. If you go in a shop and buy HDMI capture, it's probably based on this. It's very cheap, it's everywhere. And this is an Radxa X4 board, which is a single board Intel-based computer. And because we have this question all the time, why is it Intel-based, not ARM? Because on Intel-based machines, hardware encoding works out of the box with normal kernels.
Mainline
kernel, yes, which we didn't want to build ourselves.
And we will replace the HDMI capture one with a homemade board as well.
Yeah. So while we're here, some other people are getting bored and thinking how to deal with this. And this part, the display, is standard part.
Yes, it is.
From Wave Share, I think.
Yes.
Which
but
is
it can be any display. I mean, anything that does.
The rest of the things. So, for example, this is the switch. It's a standard chip that has 5 ports, and it has 4 external ports and 1 that we put in the box so we connect to the Radxa. It's a very weird switch in some regards because it doesn't have any lights, because the jacks with lights were too high and wouldn't fit in the box. So we had to make such very weird decisions at some points. But I think 2 days ago, or no, I was still like
3 days ago.
3 days ago, somebody finished the VLAN support for this. So we can actually do VLAN tagging and tagging with this switch and all kinds of weird things. Even weirder than the topology we have here, which I'm not going to show because it's horrifying. And we have the audio mixer. Now, I'm not sure if you can see this, but it has a hole in the middle because it has to fit in the box. So this is what allows you to actually have your own hardware. You can do all kinds of very strange things, and this is a hole in the board because it has to fit in the box properly. Actually, if you can see this in the switch here, the switch has an angle because it has to fit, we had to fit the fans. And you can do all kinds of weird stuff. For example, this is the power board, and the power board is something that we use to put everything we have no idea where to put. So, mostly what it does it gets power from the outside and gives power to different boards. Okay.
And it's only slightly over-engineered.
Slightly. Then you have for external, these are the chargers for the USB ports. You have 4 USB ports which are isolated that you can use to charge external things. They have overload protection and stuff like that. So if you plug on this board, this box, and put your phone to charge, there's a red light which will turn on and it will stop charging, because they allow only 500 milliamps of power, which is controllable by software, by the way. So we can push it a bit more on different ports. We decide that this is what we needed, this is what we're going to limit it, but we can even play with that. Also, we have a pass-through port that goes to the RAD, so there is no cable for it. There is a cable for it, and I'm going to explain that what we use this cable for later. And we have a temperature sensor on it, and all kinds of
fan
it
controller.
controls the fans. Yeah. And you have the audio mixer, which has 2 outputs and 3 inputs. That's it. A very simple audio mixer.
Well, it
looks
actually,
simple, but
it actually has a 4th input for the
receiver. So it has 4th input for this board,
yes.
And it has USB input and output, so you can do all kinds of weird things with it. Like one of the things we couldn't do this year was to transport audio between the boxes over the network, which we're probably going to do next year, hopefully. But this allows you to make something that's, can you imagine an audio mixer that you have 5 boxes in the room, and you can plug inputs and outputs everywhere, and they are the same mixer, for example. This is the kind of stuff we would like to do. And when if you tell this to anyone who deals professionally with audio, they'll say, that's impossible. I haven't seen this, and what I've seen close to this costs 5 or 6 figure sums in dollars. We'll see about that.
One question?
Yes?
Thank you. Is the video input treated in the same way as the slide output that you created? So if I understood you correctly, the top right box is for the laptop computers from the presenters, right?
Well, so we have 2 different kinds of setup.
Yeah.
So what you see in this room is one variation of the setup, which we came up with maybe 4 days ago. And then what we're running in the big rooms is 2 boxes. So the big rooms are 2 HDMI captures, one from the HDMI camera, which also does, gets the audio fed in via XLR, and then the other box is dedicated to slides grabbing. But what we're running here is video via USB, via webcam, and then slides grabbing via this port. So you're a little bit flexible in choosing how to run it.
So this is actually the next slide, and this is the most interesting thing that we came with for smaller events, because we have another USB 3 port. Sorry, I'm pointing at the box. But the thing is, you can plug a camera into it, you can plug the slice box, you can run the video mixer on it, and we have right now a single box that does the video mixing with a standard camera, a selfie stick for a tripod, and that's pretty much it. So you can do pretty much any kind of event. You plop this in a room, you plug some audio in it, and you're done. Now, what it lacks is an interface that normal people can use. Right now, the interface to this is USSH in the box and run commands. And that's something that's being worked on, but it's a fully fledged box. It has, you can control the audio mixer, you can control the video mixer, You can stream to multiple places. We're streaming to 2 providers right now, plus recording on the box itself. Let me go back. The Raxa has a slot here for an NVMe, and these ones have an NVMe on which they are recording right now. And the smallest NVMe in this size you can buy is 256 gigabytes, which fits a lot of video. So it's just trivial.
Well, and if you were wondering about the cost, because Vasil dropped a number of 5 or 6 figures, this box is roughly 500 USD for everything. So.
Yeah. And the sweatshop. Yeah, the sweatshop costs a bit because you have to at least feed the people. So yeah, we have the small setup over there running for the training rooms, and this is something we're still working on that a bit, but it's something that could work for pretty much any kind of event, for this kind of sized room, and because this seems to be a problem everywhere. What I've seen in different events is a lot of this stuff is actually a lot unstable. Some of that requires software to run on the laptop of the presenter, the laptop of the and there are so many different laptops, and most of them don't work. So I can't believe. And we have here a slide with ideas of what we want to have for the future. Parts of this list are not known because we came up with that, I think yesterday, are not known to the rest of the people that deal with the box. I'm not sure if they will be happy with that, but these are things we can think that we can do. Like, for example, one of the it's called video streaming for some reason, but actually nobody cares that much about the video. The most important part for any recording is the audio, because without audio, it's completely useless. And so we are looking into different ways to make better audio, like noise suppression, automatic gain control, compressors and stuff like that. Because, for example, especially with this kind of microphone, people try to do like this, and you can't hear it.
Or like this.
Yes, or like this, which is worse because that one you can't fix. Please
Yes.
don't. And the box also comes with, so it has Bluetooth and Wi-Fi on the board, and we can make you can control this probably with a phone if we write that part, which probably exists somewhere. We can have to write some glue and say, okay, here is a Bluetooth interface to the box to change slides, to change how it looks like, or something we didn't write, but we can probably load all the slides of the people talking in the box, and they can just change slides in there. They don't need a laptop, stuff like that. So
well, there is a secret second USB port which isn't exposed, but we could also use that to have a USB stick, whatever.
yeah.
There's other ideas like environmental sensors, temperature, particles per.
The point is, it's a big playground, I think.
Yes.
It's very modular, unlike almost everything else in the video world.
Yes.
And so this is a large metal plate. So that's the metal plate is a bit of a coincidence. So it's extremely helpful, but we were looking into how to mount the boards inside, and we also had the problem that the device was overheating. And we thought, why don't we put just a metal plate so we can just screw everything to it? And that also is an extremely good radiator. Now, my idea to have this as a 2 millimeter of steel was not accepted for some reason. Somebody said it weighted too much.
Well, and we want to fly these things all over the world, so I mean, saving a couple of kilos per box.
Yes, but you can use this for self-defense. And this is a very good radiator. It dissipates heat very well, and you can see how the layout looks like. And it's not hard to add stuff to it or to change it. And cutting a piece of metal is not something that's hard pretty much anywhere. Okay, if you do it manually, it's a bit a problem, but you have so many maker spaces and hacker spaces that if you go with the schematic of the metal plate and say, cut this, they will do it. Patch is welcome. As I said, the single box has no interface, and most people are not happy with SSHing into something and running commands for some reason. And we can start with some of the scripts for that. And yeah, if anyone runs a conference, if anyone is interested about that, we have built more boxes that we need. So we have 70 ready. We have pieces for 110, which will finish soonish. And we can make more. Everyone can make more. The sources are all there. But we have ones that are ready, and we're willing to lend them to use for different events for people that are interested, because this would help a lot with the video. Because you won't have to roll out the whole thing again, and you won't have to depend on external parties, because this is what we've seen a lot. You say, come do my video to some people who have no idea about this kind of event, and the results are usually not good. And we can, and it's not the nicest setup. So there are setups that can do multiple cameras, that can do have drones flying, stuff like that. It's not like that. But it's a very simple setup that does what you need.
Well, and why couldn't it do multiple cameras?
I haven't written that part.
See, it's only software.
Yeah, if somebody is interested in helping me doing video mixer that can synchronize on timestamps, it should be possible. Not with Voc2Mix, but with Voc2Mix it might be possible. Actually, I have to look into that. That's the only thing needed, because you can send the video with timestamps from the box, and then you have to just synchronize it on the other side, because otherwise you have unsynchronized video and audio, and that looks very weird.
See, and this is exactly how that happens. He just said it wasn't possible, and then we have a short discussion, and then suddenly there's an idea. That's how most of this happened.
Yeah, so this is the reason. You remember this slide? It's not rocket surgery or whatever. It's not. It's less complex after you start hacking it. It's doable. It's interesting. This is how most projects started. Hold my beer, pretty much. And the box is really made hackable. People should play with it. This is why we're giving this so people can look into it and see how it is. And yeah, people just, the only thing you need is to start, that's it. Any questions?
So I have a question about the server room setup. Why do you choose to use laptops instead of like small computers or even full computers or something?
Because laptops are cheap. We bought these second-hand for next to nothing from a hardware recycler. And so we just run them, and they cost us next to nothing.
Also, they have UPSs built in.
Indeed. Yeah,
You
interesting.
tend to trip the power at conferences for some reason.
Okay. Okay, thank you.
Do we have any questions?
On like the nice to have or like feature list of the slides.
Speaking to the
On
microphone.
the like the nice to have feature list of the slides. I think at the end you didn't mention one of them. Oh. What's a pony?
It's a small horse that's nice to look at.
You know,
I
My
thought it was
Little
some
Pony.
like AV thing I didn't know.
Yeah. Why do we have to carry these boxes everywhere? Can't they walk around themselves?
Ross,
Come on.
Ross. More questions? Okay.
So today, if you want to have support for more than a single camera, you just need more boxes, or how would you do that?
I need more boxes, plus I need to have a way to synchronize the video between the boxes. There are multiple ways for that. One of them is supporting the mixer, another is to be able to start the videos exactly at the same time and be able to synchronize keyframes on output and ingestion. And to have a mixer with enough, a physical machine with enough memory bandwidth to do that, because this is the bottleneck we're hitting on the current laptops. It's actually not CPU, it's memory bandwidth.
Like 1080p, so 1920 by 1080.
A 720p is okay actually, will be okay for cameras, but 1080 is not.
You're speaking of 1.5 gigabits only for the raw video. If you see what I mean, right?
And we're running that on 10-year-old laptops. That's why they're cheap.
Yeah,
So
okay.
any more modern machine could
This
do
is
it.
another.
So this means that AI-powered video mixing automatically just comes out for FOSDEM 2027? Or already can we expect that on 2026?
So part of this is we're lazy, really lazy. We can do a multi-camera setup in the large rooms, but that would mean we have to put people to sit in the cameras. We have to find some people for that. Otherwise,
that's the AI roles.
AI with servos,
I don't trust AI in any way. With stuff.
No?
We make hardware and give AI access to it. We're all doomed.
What could possibly go wrong?
Yeah.
Okay, yeah, thanks.
Do we have any more questions from the audience? Okay.
When is it hitting Amazon?
Sorry?
When is it hitting Amazon so we can buy and ship?
Oh, right. Why isn't it available on Amazon so you can just buy and ship? Well, yes.
It is available in GitHub. Download, build it. I think for the most, I think if you go look at what's in GitHub, you can order most of this from, so the boards you can order from GLC PCB or Eisler or whatever.
Yeah, I mean, everything is there with a BOM and everything. You can pretty much just order it from GLC PCB. So.
But have you considered commercializing it? Because after all the work that went into it?
It's our playground, it's not our
What
job.
part of we're lazy?
Yes. So I mean, I'm pretty sure some parts, even on their own, would be quite interesting. Like the remote-controlled audio mixer. I think in total that thing costs what, less than 100 euros in parts and assembled and everything. Those things commercially sell for multiple €100, and ours is better. Well, yes, it is better.
In some ways, yeah.
So, I mean, I'm sure there's something viable in at least some components, but yeah, it's our playground. We would if we had the time for it, but we're lazy.
Yeah, I think that is all the time that we have for the session. Thank you, Vasil, Gerry, and Mark for the insightful session, and thank you for making. Thank you for making this streaming possible and easy.